Okay. These can get pretty messy pretty quickly. So it really helps to try and write out as many steps as possible. I'm just going to start by covering up your answer, just so I have a little bit more space. I don't know why I copied that to begin with, but let's just get rid of this. Yank, like that. Okay. So the first thing I'm going to do is I'm going to take this exponent of 5 and I'm going to apply it. I'm going to distribute it to every single thing in this parenthesis. So that's going to be 3 to the 5th power times x to the 10th to the 5th. So I'm raising x to the 10th to the 5th power. When I raise a power to a power, I multiply. So that's going to be x to the 50th. Yikes. That's okay. Over 2 to the 5th. Y to the 6th to the 5th. That's going to be y to the 6 times 5, or y to the 30th. Times, I'm just going to rewrite this. 2 to the 3rd, y to the 3rd, 3 squared. And then this x to the negative 5, any negative exponents I have, really you can just take them. So I can write it here originally. But I don't like the negative exponents, okay? Everything's easier to simplify when they're not there. So what I'm going to do is I'm going to take that negative exponent, that base with a negative exponent, and move it to the other side of the fraction bar and make it positive. So this will become, oh, don't mind my dog. That means Amazon is here. This will be x to the 5th on top. It becomes positive, and then I can get rid of this, okay? The negative exponent means just flip the side of the fraction bar that the term is on, and then you can change the sign of the exponent. So now I can go ahead and start simplifying, quote unquote, crossing stuff out. So it's not really technically correct mathematics to speak like this, but I'm going to anyway. So I have, let's combine the tops first. So I have 3 to the 5th, 2 to the 3rd. I'm just going to leave them the way they are for right now. 3 to the 5th times 2 to the 3rd. X to the 50th times x to the 5th. That's x to the 50th times x to the 5th. That's going to be x to the 50th plus 5. That's x to the 55. And then you have y to the 3rd. Over, I'm going to leave this as 3 squared, 2 to the 5th, y to the 30th. Okay, now here's where my vocabulary is not really correct, but it's just the way I think of it. Okay, so I have 3 to the 5th on top and 3 squared on bottom. So you can either, multiply these all out and then reduce it in your calculator, or you can just say, I have, quote unquote, 5 3s on top. Like if I was just to take this thing right here and write it out, it would look like this. 3 times 3 times 3 times 3 times 3 over 3 times 3. Okay? And then you would cross out, let's pick green, this 3 with this 3, this 3 with this 3. So I'm left with 3 on top, 3 3s on top. Again, it's not technically proper mathematical vocabulary, but that's how I think of it. So these 2 3s on bottom cross out with 2 of these 3s on top. So I have 3 left. So I have 3 to the 3rd. Okay? Now, the 2's work the same way. These 3 2's on top, all 3 of them, cross out with 3 of the 2's on the bottom. So there's going to be 2 left. There was 5. 3 of them get crossed out. So I have 3 to the 3rd on top. I have 2 squared on bottom. There are no x's on the bottom. So the only x's I have are on the top. So we'll have x to the 55. And then these 3 y's, all 3 y's, are going to cross out with 3 of these. So there will be, if there was 30, there will be 27 left. And they're going to go away. So this will be y to the 27th. Okay. I'm pretty sure that the website will either accept this, or you could actually say, okay, 3 to the third, that's 27, x to the 55 over 4y to the 27th. It should accept either one. Okay, they're both fine. This one looks, I guess, a little bit better, but it's really up to you.